Welcome guys, this is Sina. Welcome to Machine Learning Mindset. In this tutorial I'm going to show you how to implement logistic regression with Scikit-Learn. So the goal is to do the binary classification task. Let's assume we have x as the independent variable and y as the dependent variable, and we want to model y based on x. So we are going to have a function f of x equals to y hat, which is a predicted y, which should resemble to y as much as possible, and it should be in the basically interval of 0 and 1. So we have a binary classification, so the output should be 0 and 1. It's obviously negative and positive. So in linear regression we could use the function f of x wx. Simply w is the weights plus the bias b, but the above function has the output dynamic range of -infinity to +infinity, and the solution is to use the popular function called Sigmoid, which is 1/1 plus e to the power of minus x. So this function is commonly used in machine learning and specifically neural networks, and you can read more about it in this Wikipedia page. It has pretty much a lot of information that are interesting, and you would learn more about it here. And I'm just going to draw a Sigmoid function simply using NumPy and Matplotlib. So this is the Sigmoid function. The output is in the range of 0 to 1, which is well suited for binary classification. And with a simple thresholding, we can easily classify some output as 0 and 1. So if the threshold is more than 0.5, if the output is more than 0.5, for example, if it's 0.6, we classify it as 1, positive, or if it's less than that, we classify it as 0. So now we form the new function f as below. So f equals to 1 over the 1 plus e to the power of minus wx plus b. So what are the optimal w and b? So we should find a solution for this equation. So turns out it mathematically can be proven that is the loss function is going to be as below to optimize and find the best w and b. So it's going to be sigma over 1 to n, and is the number of training samples, yi, which is the ground truth label, multiplied by log of yi hat, which is the associated predicted label, plus 1 minus yi log 1 minus yi hat. There's a subtle point here. For our classes, we have 0 and 1 as ground truths. So when we have a class of 0, this term cross out because you multiply 0 by this, and this term simply becomes log of 1 minus y hat. And when we have the ground truth label of 1, we simply need to calculate log of yi, and that loss function can be simplified. So there are many ways to solve this loss function, but there is no closed form for this. So it is going to be optimized, and the solutions can be found using a stochastic gradient descent, which is beyond the scope of this tutorial. So we just use Scikit-Learn here to do this optimization and find a solution for us. Now that you know what is logistic regression, let's go ahead and do some examples. So we use TensorFlow just for importing the data. TensorFlow and Keras. We use TF Keras datasets, mnis load data. So it's a simple handy function to load the Keras datasets. We import it, and all the axes is going to be normalized in the range of 0 to 1, because the initial images are in the range of 0 to 255, and this is used by TensorFlow, but it's not actually needed. Let me just eliminate those new axes because those are causing trouble. So now we have the shapes here, as you would see. So 60,000 samples, 28 by 28, and let's just showcase some of the samples. 16 of samples. I pick 16. Right, in range of number of samples to show. I'm appending the first 16 samples of the training, and based using the matplotlib and image grid, I'm going to visualize them. So here I'm using the element im2gray because it showcases images as gray. You can just play around with it, eliminate it to see what it can show you. So I'm going to continue here. I'm going to flatten the images from the size of basically number of samples 28 by 28 to number of samples 784, because Scikit-Learn likes to receive the features, which here are the image spatial dimension as a flattened vector. We just flatten all the features, the last two dimensions, to just one dimension with this function. So we go ahead. As you can see, it's very simple to implement logistic regression in Scikit-Learn. From Scikit-Learn.linear model, we import logistic regression. We form a logistic regression with maximum iteration for training of 100. There is a penalty term here which shows the L2 regularization, which basically penalizes the weights to be smaller, and it helps for overfitting problems. You need to know all the variables, but even if you don't use it, it still works. I'm just using it for just training. So here I'm just going to the official logistic regression implementation. Is just a guide. I encourage you to refer to Scikit-Learn to learn more about this thing. So there's a penalty term which might be L1, L2, elastic net, or no penalty. Default is L2. So here I didn't actually need to use this L2, so I just use it for showcasing. But even if you don't use it, it just by default use L2 regularization. So there are a bunch of different parameters here. Random states for state of randomness, the solver, which is the algorithm for the optimization problem. There are a couple of different algorithms. There's a caveat: based on your application, you should search here to see which one fits you more. I mean, usually the LBFGS is the choice, and it's by default picked by the logistic regression and Scikit-Learn. So, but you probably need to change it as you go forward. So it depends on the application. So we have here a stochastic, average, gradient descent as well. So let's just try this solver and to see what we're gonna see. So here I'm just going to add the solver as, let's say, GA. Here I am going to do this. So the logistic regression .fit basically does the training. So it fits the training data with the associated labels. After the training is done, is the time for testing. So the logistic regression .predict, we just need the X-test, because we take the X-test and this predict the classes as 0 and 1, and it does output the probabilities with the Sigmoid function, and it just does a thresholding to decide which one is 0 and which one is 1. Then for reporting the accuracy, we simply sum the number of samples that the predicted label is equal to the ground truth label, and we just add them up and take the average and report the accuracy. So here let's just say accuracy. So let's just run it to see what is going on here and what's going to be the accuracy. So it just takes a while. It depends on how many iteration you put it, and in fact how big the data is in particular, because it's very important. The bigger the data is, the harder it becomes. I wouldn't say the harder to train, the longer the training would take. Let's just be patient with it to see how long would it take. So let's just review together a little bit of this logistic regression. So in addition to the arguments of these parameters of this logistic regression, there are methods that we used, a couple of them, as you would say. So the methods are, of course, we use predict, which it says predict class labels for samples in X. That's what we predict. This is basically these methods for many different functions in Scikit-Learn, not just the logistic regression. If we would have used predict probabilities instead of the classes, it would just simply return the probabilities. And score is the mean accuracy of the score based on the test data set, and it depends on the application. If we go through the predict, let's just see. Here is what the predict does. So we do have the parameters, and we do have the predicted class labels for samples. It's just very simple. We put X, and the output is going to be the predicted classes. And as you would say, it just simply needs the data in terms of the test data, which the shape is number of samples and number of features. That's why we had to flatten the images, because it doesn't accept a shape of, like image 28 by 28. Just go back. It's still trying, because the solver just makes it a little bit longer to be trained. Let's just wait to see how long would it take. Okay, the training is done after about 10 minutes. So the accuracy is 92%. And although we get a warning that the maximum iteration was reached and it didn't converge, but that's fine. We could have just simply increased the maximum iteration here. It would take more, but you probably get a better model. So, but long story short, the training is done and the testing is done, and that was the implementation of logistic regression in Scikit-Learn. So you would see how easy it was. You just simply need to define the logistic regression object, put the fit functions, and just simply do the prediction. I hope you enjoyed this tutorial. Thank you so much for watching. Feel free to comment below if you had any questions. Thank you.